We're here at the UCT Mechanical Engineering Department. Can you tell me a bit about how you got into mechanical engineering and what attracted you to it in the beginning?
Thank you for your question. Actually, my journey has been a blend of in engineering expertise, research, innovation, and entrepreneurship. So my professional past started in mechanical engineering, majoring in production and manufacturing when I was in Iran, and I got my bachelor degree. And later I developed a strong interest in non-destructive testing methods, particularly in acoustic emission, and which inspired me to pursue advanced research during my master degree at University Putra, Malaysia. And later I expanded my focus on artificial intelligence and machine learning when I got my postgraduate diploma, and later I integrated machine learning techniques into the fatigue crack monitoring of composite materials for material evaluation and fatigue prediction, which is related to aerospace industries, and also for enhancing safety and efficiency. And my PhD research is related to the mechanical properties and macrostructural evolution in stainless steel materials or steel alloys under high strain rate blast load. And which is my PhD field is related more to the defense and energy sectors. So beyond my academia, I founded a company which is called Caspian Fellows of Industrial Technical Inspection, where I use my knowledge in non-destructive testing methods in structural health monitoring. And later I founded Mind Mover Academy, which focused on STEM and AI for Farsi-speaking learners around the world.
And as a young child, were you drawn to engineering, or where did that passion start?
So yes, when the time that I started my field, my father motivated me to study mechanical engineering, because during my high school I studied physics and mathematics. So I had a very strong foundation in mathematics and physics. So I was motivated by my dad to continue and pursue in mechanical engineering.
And your dad's a very smart academic as well, isn't he?
No, he's completely different. His field is completely different. Whatever he has studied is related to the medicals and something, so, but it's not mechanical. But I was, the time that mechanical engineering arrived to Iran, there was a very limited position for women. So that time, in the whole country, only one university accepted 60 women in the country, within the country, to study mechanical engineering. So I was top 32 to continue my study in this field.
Did you study in Iran or Malaysia mainly?
So I got my bachelor degree in Iran, and I have been working in Iran for different industries and companies at the same time. So I spent some years after my graduation in Iran in order to use my knowledge of the field, and later I moved to Malaysia in order to expand my knowledge into the research.
How strong are the universities in Iran?
Actually, there are some well-known universities like Tehran University or Sharif University, which are or American universities, which are very well-known around the world. And if people from Iran who are graduated within these universities apply for any foreign universities in any country like Canada, Germany, they know about the level of these universities and quality of these universities. But unfortunately, because of some political issues or other issues, so they are not in the top ranking of the world universities, but they are pretty well in terms of technical and engineering field.
And then moving to Malaysia, was that a culture shock or a lot of new things you learned there?
Completely was it was completely different. In fact, coming from Iran, which was deeply cultural rooted and a completely male-dominated man, moving to Malaysia and then thereafter South Africa, where the environment was completely new, the culture, the language, but at the same time incredible opportunity to learn and grow. So each challenges helped me to learn how to adapt and how to learn and how to grow and bring your perspective to the table.
Did you have many challenges coming through the system as a woman in sometimes a male-dominated industry?
Yes, definitely, because at the beginning, from the beginning of my professions, when I was in Iran, the difficulty there, I had to face. The difficulty was that I had to face the challenge and the social expectation about that, to change it to that ability and determination have no gender. So there was a time that I was the only woman in the meeting. I was the only woman on the side projects and in the workshop. So I didn't let that to discourage me. In fact, it motivated me to work harder and stand out for excellence, and also to bring the result to the table to earn the respect.
And then I presume that you've become now a mentor or a shining light for young women in this space to really make their mark?
Yes, so whatever I faced, it strengthened my confidence and my belief in creating a space for women in STEM and AI. And also I see those struggles build my foundation and my purpose in order to inspire as a mentor for women in different fields, to believe that to success in the science and engineering is possible, regardless of where you come from. But it is not just about breaking the barriers, but it is about building a pathways for others to follow and continue.
And I'm sure you've had some mentors yourself over the years. Who are some of the people that guided your journey?
At the beginning, I didn't have any formal mentors, but my dad was the earliest mentor in my life. His value, his determination, his belief in me, his motivation, belief in education shaped my confidence and approach to learning and perseverance. So later, working in the male-dominated industries, in fact, the biggest teachers was those challenges that I faced. That helped me to learn follow the perseverance, persistence, resilience. Those challenges helped me to build these characters in myself.
So sometimes the most annoying people can be your best teacher.
Yeah, of course.
What advice do you give to students to get the most out of their university career?
So as a mentor for young engineers and for women in AI, I often tell to students that don't rush through the university in order to get the degree. Use that time in order to build a foundation. You have to learn deeply, ask a question, connect to the people with different fields, and embrace the failure as a part of a journey and process. In fact, university is not a place to learn the facts. It is a place to learn how to think, how to collaborate, and how to bring the ideas, turn the ideas into the impacts. So my advice is don't choose the research topic because it is popular or it is simple. Choose the topic that you are willing and ready to struggle for. Choose the topic that brings something meaningful to the world. And at the end, just be curious, be brave, be bold, and never underestimate yourself in yourself and your potential to create the changes.
And you've had some changes in your life with the PhD wrapping up. That must have been quite a journey and busy.
Actually, during my PhD, I learned how to see the bigger pictures, to understand the importance of intellectual curiosity, the scientific integrity, and also I learned how to explore new research directions. So PhD journey for me was completely different with my other journey, apart from the different cultures and countries, but itself needs adaptability and resilience.
And then adapting to South Africa, was that another change from the Malaysian setup?
That was a completely new challenge, especially after COVID. So everything changed, people changed, we can see it that after COVID everything changed around the world. It is not specific for South Africa. But the thing is, at first I thought that because I'm living in Malaysia, everything is going to be similar to move to South Africa. And I was quite confident at the beginning. I said to my family, so I've been living in Malaysia for 8 years. I know now how to adapt and adjust myself in South Africa, so it's going to be easy. But when I arrived here, culture shock was the first thing that put me under depression. I can say. Yeah, so it was very difficult to readjust myself, especially after COVID when everything was different and people, companies, universities started to readjust and redo everything and to readapt to the new system. So yeah, it was completely different and quite difficult.
What are the biggest changes you've seen since COVID?
In my field?
In the academic, the way things are done in university.
So first of all is so the education system have to adapt to the AI technology to make everything virtual. So for the beginning of the first or 2 years, 1 year and 2 years, we started to have all workshops and seminars virtually. So so it was quite difficult and challenging, and at the same time maybe convenient, but it was challenging to have a virtual meeting, workshops or seminars, because you don't know that the audience are behind the system, they are listening or they are not listening. It is just a one-way talking. There is no eye contact. There is no communication in person, face-to-face communication. So it makes it less effective. So that was a kind of a challenge at the beginning for the new educational system. So my first research was related to the structural health monitoring when I applied fatigue loading on the composite material using acoustic emission technique, and later I integrated machine learning techniques for damage detections and to have a higher accuracy for data-driven modeling in composite materials, which is related to the aerospace industries. And later I worked on the correlation between the mechanical properties and microstructural evolution of steel alloys, particularly how material deform when high strain rate loading, like a blast loading, are applied to the materials. And then by correlating these the property changes in the material, the microstructure with the strength of a material and the failure pattern, I could gain a very valuable insights into my research, which can be used in the defense and military sectors, and which is also essential to have a safer, durable, and more resilient material, and for those sectors and industries. And at the end of the day, we're going to have a more sustainable material, focusing on a more sustainable material, safe material, and also have a good performance under different loading conditions.
And then how do you apply your research into practical applications?
The thing is that's quite challenging, because university research usually remains theoretically that's a lack of collaboration between industry and research. When we don't have a real world project scenarios to work on, then we have to focus on kind of a research that remains theoretical. And then at the end of the day, when you have any publication, any articles or research that bring a meaningful data, maybe companies find it and then they implement it and apply it for any sectors they need. But if there is no collaboration between companies and universities, then it remains within a university as a research.
Isn't that almost a shame that knowledge isn't getting fully utilized?
Unfortunately, yes, it is, because we need a meaningful contribution in order for students to understand how their skill impact the industries. We need to bring the theoretical to the more practice and practical real world scenarios and engineering. So that's a gap at the moment within even South Africa or many other countries. We need to involve more companies and organizations to get involved into the meaningful projects as a research project.
Do you ever do any consultancy work in the private sector?
In South Africa, no, unfortunately I don't, because there are some limitations for foreigners in their research and innovations. So that's the biggest challenge for me in South Africa as a foreigner, to evolve and develop my knowledge into more practice for companies. But we are working on it. I mean, now after finishing my PhD from next year, working with UCT, continue working on UCT, we're gonna bring more meaningful projects and get connected more to the companies in order to solve their real problems. So by this advanced technology in AI, machine learning, automations, companies have started to face lots of challenges, and it is very difficult for them to adapt to the new system. They will definitely, at the end of the day, need a researcher in order to help them to solve the problem. They can't solve the problem by themselves. They have to connect to the universities at the end of the day, and they have to outsource part of their problems to the university and say, we have this problem, can you please help us to solve this problem? So then we will have a research funding and we can expand it.
Exactly. And with the students, what are the areas that they're most interested in learning about?
So South Africa have a strong foundation of a talent in engineering and growing interest in AI. So we have some young professionals who are interested in field of engineering and they are capable of. So most of them are interested into the materials and mechanical engineering. But the thing is, we are just in this department of mechanical engineering, so we see the students here. So we are not aware of other departments to see how many students they have, and if there are many interest in other fields as well or not. It is just specific for in mechanical engineering or material science. But for us, we see plenty of students who have lots of curiosity to know more about the mechanical engineering and growing interest in AI.
Are there more females enrolling into mechanical engineering?
No, unfortunately, we still have less females in field of mechanical and materials engineering, which is quite complex and complicated. And the other side is like many students, no matter the gender, prefer to stop their studying when they receive their bachelor degree. We don't see lots of enthusiasts to continue their master degree or specifically PhD. We have less students in the PhD, especially after COVID. And because of the job opportunities, lack of employment, so they have some kind of insecurities in their mind about a job employment. So they prefer to focus on their career rather than on their study. So that's why the time that they get their bachelor degree, they exit the universities because they want to go to do something more practical. That's why I'm saying if the companies get involved into the research, into universities, students find themselves more, involved into the projects and can find how the skill can impact the industries. That's very important.
And following on from that, what would you say is the role of AI developing and how it interacts with education?
In terms of AI in education, there is a great enthusiasm, but we need more structure and interdisciplinary program. For example, we need some courses that teach us how machine learning techniques can be used in material science or can be used in manufacturing. So then later we can apply the traditional engineering into the AI and bring some analysis into the material analysis or into the automations. So those restructuring and disciplinary are necessary in order to bring the AI into the educations. And also, another thing is when it comes to the mechanical engineering, AI is going to shift towards more data analytics. So it is like the mechanical engineering as a traditional, but people who knows how to integrate AI into the mechanical engineering, mechanical knowledge is going to have the future. because at the same time of knowing the mechanical knowledge, you also need to expand your knowledge into the computational and analytical skill, right? So this is how we integrate intelligence system into our knowledge in order to expand it, especially for predictive maintenance, for predictive failure, which when we involve AI, implement AI and machine learning into a field, we can have a faster analysis and with more accuracy.
Absolutely, and failure analysis is a critical part of engineering. What are some of the areas of interest and projects that you've worked on, and how the demands of air and space travel and the military components put strain on materials?
Absolutely. Failure analysis is one of the most fascinating and important aspects in the engineering fields. It helps us to understand why materials fail or deform, and at the same time we can understand how to prevent it in the future. So the main area of research lies into the analyzing of the relationship between materials' internal structure and its mechanical or microscopic response under different stress, particularly in the metallic materials and composite materials. So we have different loading conditions when we apply loads to the material. So we divide it into different strain rates. So low strain rate, medium strain rate, high strain rate. So when we talk in a low strain rate, it is like, let's say, so we can't say like fatigue cycling loading is the lowest strain rate, but considering that when you apply loading slowly to the material, right? Material have a sufficient time in order to deform. So definitely inside the material, the microstructure will be different and react differently, and material because of the sufficient time, material can be more ductile. So, but when it comes to the high strain rate loading, because it happens very sharply in just maybe microseconds, material doesn't have enough time in order to deform, and maybe sometimes a sudden repressure happen. And then that sudden loading makes the deformation within a microstructure completely different with the low strain loading. So, if we integrate AI and machine learning into this kind of a data, then we can implement a predictive modeling or for failure pattern recognition in order to have a higher accuracy of the modeling and have to have a more reliable modeling, and also to have a safer and durable material with a higher performance in different industries.
Absolutely, and in the military aspect, what areas do you look at there?
So my PhD is related to the stainless steel material. So some famous stainless steel material that is being used in the defense technology and defense sector and military services, like a synthetic stainless steel or duplex stainless steel, which is very versatile and durable material. So in military sectors or defense, most of they just relate to the highest strain rate loading, because it is just a sharp attack, so we call it highest strain rate load. It's a ballistic impact or explosion. So my PhD is related to the explosion. So when we apply the explosion doesn't do as slowly, so you can see the rocket coming down to you, it is very sharp. In microseconds, it can make a destruction. So what I did during my PhD is we applied the explosion to the material, and afterwards I investigated what happened within a structure, what is the internal material strength to the failure pattern, how we can correlate the internal strength to the failure patterns and the microstructural evolution. What happens within a microstructural material, and how we can strengthen the material when the high strain rate loading or blast or explosion or ballistic is happen, how we can prevent the failure, make it more durable. So we can't prevent it 100%, but we can make it more durable. So some materials may be used in the bullets or something for defense technology. So those material that is being used in the bullets should have a durability, must be very versatile. when it attacked any sources, it must be very durable. So it all related to whatever I have studied so far.
Is that why silvers are quite popular in some military applications?
Yes.
With durability?
Yes. And material performance, durability, material performance, and how material maintain its integrity under high strain rate loading, under ballistic or explosion.
Interesting question. Mars, is that a realistic target for human travel or a waste of time with our current technologies?
I believe Mars is a realistic target for human travel, but it is extremely challenging because for us at the moment because of the current technology that we have. Considering that long travel time, radiation exposure, a life-spanning support, and also the harsh environment in the Mars requires very careful planning and highly reliable systems that we lack at the moment. But the robotics and AI and changes in the propulsion are bringing us closer together and make it more achievable. And AI and machine learning are also key enablers in these projects. In fact, they help us to analyze vast and huge amount of the data. We can monitor the spacecraft health, and also we can support autonomous decision making. In fact, it's something that human can't intervene in the real time. So this is how AI and machine learning are key enablers in this kind of a project. And at the end of the day, AI help us to push the boundaries to explore about space and Mars, and also reduce the risk and make it more achievable.
Are we probably more likely to see an unmanned mission go first?
I think so because of the environment and the risk in that harsh environment in Mars. We definitely need a machine and robots to go there first to send us valuable data from that space to that then scientists can check and analyze and investigate how they can bring the life into that space, make it more, more habitants to that space, and make it more reliable and expandable.
You're a mathematician. How accurate do you find AI and machine learning to be in terms of results?
So as I said, AI and machine learning can help us to make something like autonomous decision making rather than for human being that human being can intervene in the real time. So also AI can help us to to analyze vast amount of the data. So this is how AI and machine learning are important in that case.
What's your favorite metal and why?
So my favorite metal is steel, particularly austenitic stainless steel, because it is very versatile and very durable.
Sorry, did you say stainless steel?
Austenitic stainless steel. We have different stainless steel.
Maybe you can uninitiate. What is that? What kind of steel is that?
It's an austenitic stainless steel. So we define a stainless steel based on their crystal structures. It is more about the knowledge and expertise in material science. It's very specific. So we define the stainless steel based on the crystal structure. So we have an austenitic stainless steel, ferritic stainless steel, duplex stainless steel. And so austenitic have an FCC crystal structure, face center cubic, and ferritic have a body center cubic, which is BCC, and duplex have face center FCC and BCC. So this is how we define the stainless steel family. So each comes with their own specific properties within a material. So austenitic stainless steel, which has an FCC crystal structure, is very versatile and durable. It maintains its integrity under even harsh environments. The material has a high concentration of chromium, which provide corrosion resistance resistance and at the same time good formability to this material. What really inspires me about austenitic is how its microstructure can be engineered and to be used in different performance and different industries. So that's why I like the material, because this is the austenitic is also being used as a component in the medical instrument, to the spacecraft, to the defense. It's very widely used and very popular during the among the stainless steel materials.
And would that be a prime material for space travel?
No, I don't think so, because I think for space travel we need lighter material. To be honest, for a spacecraft, aerospace, and also for defense sector, these industries are relying on the highest strength to weight ratio material, which means they need a very durable and versatile material, but at the same time lightweight. Something. So I can say something like composite, because composite is not highest strength material compared with a steel material, but it is light. So that's why we have lots of in the body of an aircraft. Most of the body is made from composite material, because it is a lightweight. So then airplane doesn't need lots of fuel in order to travel. Otherwise, they will charge us 10 times, if they use stainless steel materials. So I believe that these sectors, move toward titanium, nickel material, which are durable but at the same time lightweight. But it also brings the innovation to the research in order to decompose it and recomposite the material for a better performance.
If you look at the design, a little bit off topic, but you look at the design of airplanes over the last 50 years, it hasn't really changed, like the 747. Why are those designs still relatively, have they just found optimum really?
So considering the limitation of the size of the airplane and the number of people that they want to accommodate during the flight, so it brings sometimes lots of limitations in order to redesign the airplane. Because if we design an airplane for 10 people, then the price will be huge, so it is not affordable for many people. So that's why it is difficult to re-engineer the design of an airplane to accommodate the same number of people, but at the same time, what can we do inside the airplane? But what we can do is to change the material from the body outside, because when you use lighter material, you need less fuel and you will have a higher speed to reach to the destinations. So this is why now aerospace companies are investigating and also investing into the new materials to make it lighter.
Exactly, it's all lightness and strength.
And that's a important factor that these sectors are focusing on.
What minerals or materials might be the most sought after in 10 to 20 years' time as technologies develop? Copper, I see, is also used a lot in AI and tech. Is that going to continue, do you think? So looking ahead in 10, 20 years, I believe material that support energy efficiency and miniaturization and sustainability will be the material in the futures. So material something like a lightweight alloys and graphene, or rare earth elements or rare earth metals, also semiconducting materials that can handle high power density for AI and clean energy technologies. So did you ask about the copper? Is copper still going to be that conductor of choice in 10, 20 years' time?
For copper, it will remain a valuable material, but we will see new conductive materials such as graphene composites or even superconductor that might completely or partially replace it. So especially in the AI hardware and also in quantum computing. So these materials can transfer data very faster and with a lower energy loss, which is very important in the next generation of intelligent system.
And I hear gold's also quite important for microchips. Is that something you study at all, gold? Or?
No, actually, I didn't study about a gold, which is not my expertise, but I believe that gold can be used in the microchips.
All the women love gold.
Yeah, we need smarter materials. So smarter materials is going to be my next project for next year that I'm discussing with UCT at the moment. And it will be something new, completely new, and we're going to bring something massive into the countries in terms of new materials. So the future will be rely on the smarter, more efficient and durable materials.
Is that how you define a smart material?
I can't reveal the details now. At the moment it is highly confidential, but it is very interesting.
Okay, so watch the space for details.
Yeah. Yeah. But I'm pretty sure that gold is not going to be part of any.
As commodity prices continue to rise, is there a fear amongst certain aerospace, space, and air travel that certain materials will become too expensive, or does that just get passed on to the customer?
Yes, actually, rising commodity price have been a growing concerns, and especially in the industry like aerospace and defense sector. So, where materials such as a composite, nickel, and titanium are being used commonly, and but in many cases, the initial burden of a cost will be absorbed by the manufacturer through the long-term contract. But over the time, definitely will be passed along to the customers in form of a flight cost, in form of the services, or even defense technology, you know. But all is not negative, you know. It has driven the innovation into the material. Many organizations are now investing into the material recycling, additive manufacturing, and also AI-driven design optimizations that brings the innovation into the research and also reduce the waste and improve the durability of the materials. So this help to offset the material cost while maintaining the performance. As I mentioned from my experience, South Africa has a strong talents in terms of engineering and growing interest in AI. But I have noticed some challenges. The first is limited access to the advanced laboratories. Second is research funding, and also modern computational tools. These can slow down the innovation and experiments. And at the same time, these resources are essential for hands-on learning and for practical innovations. So specifically in the areas like material testing or mechanical engineering. Another area was, as I mentioned earlier, was the integration of between academia and industry. You know, where most of our university research remains in the theoretical rather than into the real-world applications and scenarios. So strengthening those partnerships through internship or collaborations, you know, so collaborative projects can help us to expand our knowledge and research, and also would give students to think that their skill have impact into the industrial landscape. And in terms of AI education, also we need to restructure the program in order to implement AI and machine learning into different fields, specifically for engineering, mechanical materials engineering. Apart from a knowledge and expertise, I can say that one of the biggest challenges that I face in South Africa is the visa and permanent residency. As a foreigner, you know, a foreigner really brings lots of expertise and global perspective to the country. And the challenge in the visa and permanent residency limits our opportunities our collaboration into the research and innovations. So I encourage a greater inclusion and collaboration in South Africa would help us to develop and expand our knowledge, and also South Africa can get benefit from the talents that are within the country at the moment. So maybe South African Home Affairs needs to renew the system. We have AI around. I believe AI is less biased, and can transfer the data faster, analyze the data faster, and more reliable. So they can implement AI into the system rather than using a human being. Also, they can. There are plenty of options that they can work on. They can ease them administrative and backlogs and delaying time, and maybe they need to set up a new point-based systems and ease the qualification verifications for foreigners. So these are the challenges that I have experienced so far in South Africa.
I'm sure if you were in Australia or something like that, you would have got your visa a lot quicker with your skill set.
I didn't experience the overseas and other countries, but I'm pretty sure that there is a system everywhere. There is a standard system that if you go through the process, then you can receive, you can achieve what you want, without huge delay. We have a huge delay and backlog in South Africa that makes it very frustrating and exhausting, and it makes very difficult for us because in companies prefer to invest on someone that they know she or he works permanently because they are investing in you, right? So they don't want to hire you even as a part-time to know that you're going to leave the company within a year or within 2 years because of the visa, you know what I mean? So many companies, the first option for many companies is, are you a permanent resident here? When you say no, they say, oh, we are sorry, we can't hire you, and are you a local person? So that's really frustrating for me, coming from interdisciplinary knowledge and a strong background in mechanical engineering and materials engineering, still to find my niche in South Africa, and I can't use my knowledge, I can't help the companies. Why? Because I'm a foreigner and I don't have a permanent residency.
So South Africa is missing a real opportunity to maximize on the foreign skills.
Yeah, definitely. Yeah, 100%.
Do you find companies coming to poach postgraduates, graduate students from university here?
I don't think so. With AI systems that are on, it is like students will go and grab the companies rather than companies.
So it's easy to find work.
It is like, unfortunately, companies are more relying on the local people, rather than the knowledge and expertise. It is like, as long as you're local, you're hired. Doesn't matter what knowledge you have. And then they face the problems. And they know that these problems comes from a lack of skills and expertise, but they don't want to accept it. That makes it very challenging and bring the economical crisis to the country. When you don't open your door and border for foreigners that can bring lots of expertise and money to the country to invest, knowledge is money, So when you don't open the border, then definitely economic crisis happen within the countries because there is no skills, there is no knowledge, there is no expertise. So we cannot say it is no one in South Africa have this knowledge, but there are some critical skills that not everyone have it, that some company need it.
Can you explain some of the efficient and advanced methodologies you've developed that ensure safety and reliability of materials under extreme conditions?
What makes my approach advanced is integrating machine learning techniques into the acoustic emission data and to the loading condition to the composite materials. So instead of relying only on human interpretations, AI can identify subtle signals, AE signals, and that indicate the crack initiation and propagation in the materials. So this allows for more real-time monitoring and damage detections and predictions of the material failure with a higher accuracy and more reliable analysis. Another methodology that I have also applied was a multi-scale material characterizations. So from the designing a miniature specimen for my test, for my PhD, to combining the micro scale and macro scale together. So to understand how micro changes in the material affect the macroscopic performance of the material in the development of advanced and more reliable materials in the future within steel alloys. Also for energy sectors or defense or aerospace sectors. And overall, my expertise is a bridge between experimental research with multidisciplinary and intelligent data analysis.
And with that, you've won quite a few awards over the years. So what has been the key to your success and your proudest achievement?
First is adaptability. Second is resilience, and third is be open to any changes. So when you're in the growth happens when you're out of comfort zone. You know, when you're in your comfort zone, you never grow, you never learn something new. But when you're out of comfort zone, you can experience, you can explore, and you can learn and grow at the same time. In fact, I believe that you definitely hear that some people believe that AI is going to replace the human being. AI is going to replace. No, AI is not going to replace the human being. In fact, human will be replaced by other humans who are using AI. It is not about AI itself. It is about how you adapt and adjust and shift yourself towards the technology, advanced technology. How you are ready to grow, to sustain the difficulties, to learn how to learn, to learn a new skills. AI brings lots of opportunities to our life, but we need people who are ready to learn. We need people who are out of comfort zones. So for me, it was like, I'm still at this time, I'm always ready to get out of a comfort zone. I'm always ready to learn something new. No matter how old I am, no matter how many years or how many experience I have, but I'm always ready to something new. And new things always excites me. It is not very easy at all. Just because I'm handling this well doesn't mean that it is easy. No, it is very hard, it is very difficult, but I'm ready to accept the challenges and struggle to learn something new.
Absolutely. And do you ever study deformation mechanics, failure analysis in infrastructures, bridges, roads, things like that?
My field, actually bridges and infrastructure or other civil engineering structures are used, some commonly materials are being used in these structures like composites, metals and concretes, So my field, my area of research is mostly concentrated on composite materials and steel materials. But we use steel in the support beams in the bridge and infrastructures, which is related to my research when I'm studying about materials strengths. So that can be applicable in that engineering, in that field. And also, reinforced concrete, use a steel bar inside that compressed concrete in order to strengthen the materials. Also, knowing the mechanical properties of the material, steel materials is important. So I can relate, I'm not directly working in that field, but my research area is related to that field.
Precisely. So you always have to be up to date with all these developments of the new materials coming through.
Definitely. I mean, it is ongoing. Knowledge and technology is evolving very rapidly, and a huge amount of data is available compared with 4 years ago, you know. And everything was more simple before COVID, in fact. So yeah, new materials are emerging day by day, day by day. MIT, Harvard University, Oxford University, they're all just decompositing and recompositing materials and bringing in new materials. That is a huge shock to us. You know, it is like you are in the middle of your project or your research project. Suddenly, a news come up and a new material is designed by MIT. You know, and then, oh, what's going on? You know, you think that you are drawing a meaningful, you know, data for a specific part, and then now suddenly everything changed. So that's why I'm saying that we have to be ready for changes. Research is not something that you think it is fixed and this is a research, I need to follow this instruction to become a researcher. No, not at all. There is no instructions. You have to be very flexible and also resilient in order to become a part of the research. Needs lots of hard working dedications in order to bring a meaningful impact into the industries.
And finally, with students, where's that fine line between using AI as a tool and using it as a copying device?
So, what specifically you want me to explain?
What I can say about, you've got a lot of papers published. Do you ever run into plagiarism problems, people stealing your work?
So that's a great question in research. So that was supposed to be my advice at the end of our interview for the students. But I can tell you now, with the AI tools availability today, and with the huge amount of data which is out there, if you just Google it, you will see lots of resources and something. You know, I remember that at the beginning of my PhD, when I searched something about relevant to my topic, I couldn't find anything. You know, I could hardly find resources to cite into my thesis. Now, if I search the same topic every day, I will see new publication. I will see new publication. I will see, and it is huge, and it is very impressive, and at the same time shocking. And so a student shouldn't get panic in this case because of the vast amount of data. But the thing is, so I'm a reviewer for international journals. As a reviewer, what I encountered was the overlap between the manuscript that was submitted to the journal with the existence work that is already published, but the author wasn't aware of it. Usually, unfortunately, this led to rejection, not because of the lack of the value of the research, but because the knowledge of the field wasn't communicated clearly. So it is very important to know that someday you come up and see part of your study has been already published. This is a new challenge in research at the moment. This is what I experienced as well, you know. So when I submitted my second paper to the international journals, they just said, we already know about this, you know, and then it was rejected. We already know about this. What is a novelty? What is new? And you have no idea how difficult and tough time I passed through in order to bring a new approach or narrative to set apart my research. It's very important.
From your own research.
Yeah, it's very important because of the availability, the huge amount of availability. Millions of publications are happening around the world, and every day new topic. And many researchers are integrating machine learning techniques into the data, and it is huge. Once upon a time, there was a limitation number of papers or words. For journals, for example, number of papers shouldn't exceed 20 papers. Now we have a paper which is 60 pages. You know, it says a lot about the knowledge, how knowledge is expanding and developing, that we can't accommodate it within 20 pages. So what is important for students is like, first, be careful what topic you choose for your research. And the second is be open to the changes, because you might see the similarities that is already published. So it doesn't mean that your research is meaningless, but you have to develop the skill, which is, we call it storytelling. This is a new skill in research that I recently talked to the postgraduate student of this year, that storytelling is very important for students because I experience it. So you have a data, but you should know how to approach it, how to tell your story, how to communicate your research in order to set apart your work. That's an important skill at the moment. So development of storytelling skills is much more important than technical expertise, at the moment. So definitely we will have. It is inevitable because it happens. The same similarities in the near future, even now, it is happening. This is what I have experienced as a reviewer.
Absolutely. And anything else you'd like to add?
I can say my advice to universities is like workshops and seminars needs to evolve continuously and needs to be changed. We can't focus on the same topic, similar topic every year because it doesn't inspire the students. Now we have to shift our focus because of the AI and technologies and developing the knowledge in everything. We need to shift these kind of seminars and workshops towards how to adapt, how to critically analyze, how to learn, into this field of AI and advanced technology. So in fact, in the future, the skill is not what to learn, but future skill is learn how to learn. So this is how we need to shift our education systems towards better understanding and adaptability and to develop the skills of data analytics. And university must be open to the AIs because I see there are some resistance. Still, we have some people in academics that don't want to accept that AI is around. Because the problem is they think that AI is going to replace them, but it is not a replacement. It is how to implement it and use it into your field. And if you resist, you will be removed, to be honest, no matter what place you have in the universities. But if you don't know how to use AI into your field, how to implement machine learning techniques, you will be removed by people who have the data intelligence system knowledge.
So practically, how would you implement AI into a lecture?
So lecturing, I'm not a lecturer.
Or do you do more one-on-one mentoring?
It is more important about students to implement AI into their research and learning rather than into the lecturing, because lecturing is a face-to-face and in-person, teaching methodology.
So there's less change there, yeah.
But when it comes to the marking, when it comes to the exams, yes, you can make it automated. How?
Automated marking now?
Yes, we can make it automated. How? For example, we can design a system, an AI system, that when students are taking their exams on their system rather than on the paper, making it on the system, AI can analyze the level of talent of the students. How? By shifting the question from the easiest to the hardest, and then shift the question. If the hardest student can't answer it, then level down to the easiest, and then you can find the talent in the students. And then you mark the students based on their talents, not based on the, something that you learned and you memorized during your learning, because we want the students to learn effectively, to use their talents effectively and efficiently in the industries and in the universities. This is not a competitive environment. This is an environment that people must learn and learn how to turn the ideas into the impact. So it doesn't matter what marks you receive, but as long as students are motivated to continue learning, that's the most important thing, especially with AI things around the world. Another thing is, when students, for example, have a bad time before the exam, So what you want to do? The students maybe is highly talented, but have a bad time one night before, and definitely he or she can have a good marks. This is how we implement AI into the system, because AI can recognize and can do sentimental analysis through the students' answers and say that this student wasn't in a good emotional or mental state. That's why this is a lower mark. So this is very important than focusing on, oh, I am a number one in the class, I am a number two in the class. You know, this is how lecturers can use AI into their exams and marking, and also AI can be used into the lecturing.
Sounds like a smart exam.
Yeah, more practical, impactful, and meaningful.
And is there any danger that universities, if they don't adapt to AI, will get left behind and people will just dive straight into that after school?
Hopefully, universities started to adapt and adjust to the AI systems. That is a very hoping matters that is happening now, even in South Africa, even at UCT. You know, they started to adjust and adapt. They are still at the beginning, but they are taking the actions. You know, they didn't stop, because in the future, all the universities around the world have implemented the AI into the system, and if you don't have AI, you can get connected, you can get linked. Because it is all about, when you contact the universities, they will give you the link that is connected to the AI, to the cloud or AI systems that can analyze the data or something. So the basic knowledge of AI is important, but developing your system into the more autonomous decision making or more automated system or intelligent system are also important for universities.
Amen. Well, thanks very much for your time.
My pleasure.